Hi students, very good morning, welcome back. So in the last section we discussed about the different branches of chemistry and the importance of chemistry in our day-to-day life. So in this section we are going to discuss about some basic concepts of chemistry. In plus 1 there are 14 units, 14 chapters. The first chapter is some basic concepts of chemistry. Second chapter, structure of atom. Third chapter, classification of elements and periodicity in properties. Fourth unit is chemical bonding and molecular structure. Fifth unit is states of matter. Sixth unit is thermodynamics. Seventh is equilibrium. Eighth one is redox reaction. Ninth is hydrogen. 10th unit is S block elements. 11th unit is P block elements. 12th unit is some basic concepts of organic chemistry. 13th unit is hydrocarbons. And finally the 14th unit is environmental chemistry. So today we are going to see some basic concepts of chemistry. Some basic concepts of chemistry. So unit 1. Unit 1 is some basic concepts of chemistry. The first unit is some basic concepts of chemistry. In this unit, we are discussing about matter, its classification, measurements of the properties, law of chemical combination, mole concept, stoichiometry of the reaction or stoichiometric equations. And finally, we do some problems based on the stoichiometry. And concentration terms in solution. Let's discuss one by one. First part is matter. In the last section we discussed about the importance of chemistry and we just revised matter. What is matter? Matter is anything which has mass and occupies space. Matter is classified into mainly two. One is based on its physical state. Second one is based on the composition. The first classification based on the physical state and second classification is based on the composition of the matter. In physical states, how many physical states are there? We know that solids, liquids, gases, both ancient condensate, fermions and quarkions. Okay, as we know, the 7 states of matter. How many states are there? 7 states are there. Solids, liquids, gases, plasma, both ancient condensate, fermions and quarkions. As you know that. Then in solids the particles are tightly packed. They have definite shape, definite volume. Diffusion is less, practically zero. Liquids, the constant particles, atoms, molecules, etc. They are loosely held and loosely packed. That's why they can move. They can move. Then the liquids have no definite shape but definite volume. Kinetic energy is higher than that of the solid particles. They can diffuse, they can flow. Then gases, the particles are very loosely packed or very loosely arranged. Lot of space between the gas molecules. That's why gas molecule can be mixed with each other. Very freely mixed. Not definite shape, not definite volume. But the volume of the gas is the volume of the cylinder. The kinetic energy of the gas molecule is very, very high. That's why it has high diffusion nature. It's flow very fastly from one region into the another region. Okay, plasma is occurring high temperature region. Plasma state is occurring stars. Okay, last class we discussed about the fusion reaction in solar system. In sun, the hydrogen molecule combines to form helium. Okay, very high temperature occur, that is a plasma. In plasma, the matter exists as gaseous atoms, ions or electrons. Then Bose-Einstein condensate, as I already give the information, the temperature of the universe decreases, the whole universe become a single atom, that is Bose-Einstein condensate. Fermions, another states of matter, fermions. Enrico Fermi is a Jewish scientist. Then last is quarks. Now we move to the next classification based on the composition. At the macroscopic level, micro means small, macro means large. At macroscopic level, the matter is classified into mixtures and pure substances. Mixtures and pure substances. So the classification based on composition to mixtures and pure substances. What are mixtures? Okay, we buy a mixture from the bakery. What are mixtures? In mixture, many components are there. Many substances are there. Okay, so in mixtures, many components are there. Similarly, in a mixture, in chemistry, the mixture contains two or more components, two or more substances, two or more chemicals, two or more atoms or particles. Okay, so matter is classified into two based on the composition. Matter. The first classification is mixture. Second is pure substance. Pure substance. In mixtures, there are two subdivisions. I think you know that homogeneous mixture and a heterogeneous mixture. What are they? Homogeneous mixture and a heterogeneous mixture. So mixture is classified into two: homogeneous mixture and heterogeneous mixture. Homogeneous mixture and heterogeneous mixture. Then pure substance. What are pure substance? Pure substance contains only one type of particles, one type of substance. In pure substances, we divide into two. One is elements. The first division is elements. Second division is compounds. So in mixture, two subdivisions: homogeneous mixture and heterogeneous mixture. In the case of pure substance, two divisions is there: elements and compounds. Let's discuss one by one. One is homogeneous mixture. First we go to discuss about the mixture. Hope you understand the classification of matter based on the composition. Okay, based on the composition, matter is divided into two: mixtures and pure substances. Homogeneous mixture, heterogeneous mixture. In pure substances, elements and compounds. Elements and compounds. Clear? Okay. So we discuss about homogeneous mixture. What do you mean by homo? The scientific name of human being, Homo sapiens. Homo means same. So homogeneous mixture having same composition. Homogeneous mixture having same composition. The components are mixed in a fixed ratio. The components are mixed in a fixed ratio. So in homogeneous mixture, the composition is uniform throughout the mixture. The composition of the mixture is same throughout the mixture, or the composition of mixture uniform throughout the mixture. For example, sugar solution. When we take a glass of water and add 1 tablespoon sugar and stir it, the sugar is completely dissolved in the water. The concentration of the sugar above, below, then middle of the glass, side of the glass, everywhere it is same. Everywhere in the glass is same. That means the composition or the ratio of components are uniform. So example for homogeneous solution or homogeneous mixture. So homogeneous mixtures, the composition is uniform. Composition is uniform. Example, sugar solution. Sugar solution. Can you say one another example? Yeah, definitely salt solution. Salt solution. Another example, air. The mixture of O2 and nitrogen is thoroughly mixed. Okay, it is thoroughly mixed. The oxygen do not concentrate at a particular region. The nitrogen do not concentrate at a particular region. So when the oxygen and nitrogen is mixed, the composition is same throughout the mixture. So you collect more examples. I give only 3 examples: sugar solution, salt solution, air or mixture of O2 and N2. Okay, as you know that in atmosphere 78% nitrogen and 21% oxygen. Remaining 1% is other gases. Okay, 78% nitrogen, 20.98, that is 21, approximately 21% oxygen, 1% consists of other gases. Okay, yes. Then next we go to the heterogeneous mixtures. We can say that what is heterogeneous mixture? In heterogeneous mixture, the composition of the components are different. In homogeneous, the composition of the components are same or uniform. But in heterogeneous mixture, the composition are different. The composition are different. Can you say one example? Muddy water. We take muddy water. In muddy water, the mud and water do not mix uniformly. Just keep it for some moment. What happens? The muds are settled down. The muds are settled down. Starch solution. Starch solution. At home you take some starch solution. Starch solution. Kanyala. Gruel water. After some time, the starch settle down. Okay, a thick concentration or more starch concentrated at the bottom, on the top it is less. So it is a best example of heterogeneous mixture. So muddy water, starch solution. Another one, can you say? Sand and iron filings. sand and iron filings. Mannum irumbu podi. When the sand and iron powder mixed, it is not thoroughly mixed. It is not mixed uniformly. In soil, the sand and iron filings are not thoroughly mixed. Not thoroughly mixed. So, these are the examples. Another example is milk. I think you think milk is a homogeneous mixture. No. Milk is not a homogeneous mixture. Milk is a heterogeneous mixture. The fat dissipates in water. Milk is an example of colloid. I think you heard about colloids. So, fat dissipates in the water is milk. Milk also contains casein, proteins, then lactose, sugar, etc. Anyway, milk is a heterogeneous mixture. When you take some sugar and tea powder and try to mix, can you mix thoroughly? Can you mix the tea powder and the sugar uniformly? No. So, these are the examples of heterogeneous mixtures. Are you clear about the homogeneous and heterogeneous mixtures? Okay, yes. So, the classification based on physical state and composition is over. In physical state, there are 7 states of matter. In based on the composition, mixes and pure substances. So, mixture is over. Now we move to the pure substances. What are pure substances? What do you mean by purity? 100% purity means it contains only that component. Okay, purity, which means the substance contains only that component. So, pure substance consists of only one type of matter, only one type of substances. Are you clear? Pure substances consist of only one type of substances or particles. Pure substance can be classified into 2. First one is elements. You need a example for heterogeneous. You take it. Heterogeneous mixture. One is starch solution. Starch solution. Second one is muddy water or mud. Third one is you can take milk. Milk is a heterogeneous mixture. Then sugar and tea powder. Sugar plus tea powder. And you collect more examples. Okay, and write it in your notebook. Then we move to the pure substances. Pure substances. Pure substance consists of only one type of matter or only one type of particles. In pure substance, the first one is elements. Elements. What are elements? Elements consist of only one type of particle of atom. What are elements? Elements consist of only one type of particle of atom. One type atoms മാത്രമുള്ള one type atoms മാത്രമുള്ളതിനെയാണ് നമ്മൾ elements എന്ന് വിളിക്കുക. What are elements? Elements consist of only one type of particle of atoms. They may be atoms or molecules. Okay, elements may be atoms or molecules. Only one type particles is called elements. They may be atoms or molecules. For example, gold. The symbol of gold is A. You know that. Silver. Silver is an element. Copper is an element. Hydrogen is an element. But exists as molecule. Are you clear? Elements are maybe atoms or molecules. Elements are atoms or molecules. Not maybe. Elements are atoms or molecules. Oxygen is an element but exists as molecule. Nitrogen is an element but exists as molecule. Okay, so elements can exist in the atomic state or in the molecule state. So what are elements? Elements are one type of particles. They may be atoms or molecules. They are atoms or molecules. Gold, platinum, copper, etc. Sodium, potassium. These are elements as atoms. But hydrogen, oxygen, nitrogen, fluorine, chlorine, etc. are molecules. Atoms combine to form molecule. What are molecules? Atoms combine to form molecule. Molecule of a same atom. So elements, in the case of elements, atoms of same elements combine to form molecule. Then second one is compounds. Are you clear about the elements? Okay, you collect more example for elements. Then second one is compounds. Compounds. What are compounds? Compounds are formed by combination of two or more atoms of different elements. Compounds are formed by combination of two or more different atoms. Same atom, it comes under element. H2. H plus H, H2, it's an element. O plus O, O2, it's an element. In compounds, the atoms of different elements combines to form a molecule of compound. Atoms of different elements combine to form a molecule of compound. For example, water. Different atoms, hydrogen and oxygen, carbon dioxide, carbon and oxygen. Then in sugar, glucose, C6H12O6, carbon, hydrogen and oxygen. Okay, ammonia, NH3, nitrogen and hydrogen combines to form ammonia. Nitrogen oxides, NO2, nitrogen dioxide, which is a compound, a molecular compound. Different atoms are combined. Different atoms are combined. So, hope you understand the elements and compounds. In elements, one kind of particles. They are atoms or molecules. Compounds are pure substances formed by combination of different atoms. Okay, then we move to the properties. Properties of the matter. Properties of the matter and its measurements. What are properties? What are properties? The properties of matter. Each substance having a unique characteristics. Unique property. Okay, so these properties are two types: physical property and a chemical property. Each substance have a unique characteristics, uniqueness. Okay, so this is known as properties. The properties can be divided into two: physical property and chemical property. First one is physical property. Okay, first one is physical property. What do you mean by physical property? What do you mean by the physical properties? By physical means. Okay, by physics. Enne kanda ningalku ariyam ekadesham ithra height undu, color idana. Okay, then complexion ഇതാണ്. ഇതൊക്കെ നിങ്ങൾക്ക് ഒബ്സർവ് ചെയ്യാൻ പറ്റും. അപ്പോൾ ഒബ്സർവ് ചെയ്യാൻ പറ്റുന്ന പ്രോപ്പർട്ടീസ് ആണ് ഫിസിക്കൽ പ്രോപ്പർട്ടി. നമുക്ക് ഒരാളെ കണ്ടാൽ ഏകദേശം ഹൈറ്റ്, then weight, approximately height, weight, then color, then the complexion, hairstyle, etc. We can observe. So such properties are called observable properties. Physical properties are observed. Physical properties are observable properties. In chemistry, the physical properties are melting point, color, odor. Odor means smell. Okay, odor. Then boiling point, density. Okay, then physical state such as liquid, solids, etc. So by we can measure the properties physically is called physical property. Okay, can you understand the mind of a person? No, it is difficult. It needs some time. So similarly, chemical properties which need the measurement by a chemical reaction. So chemical properties are measured by a chemical reaction. What are the chemical properties? Bond length, the distance between the two nuclei of bonded atoms. Okay, bond length, bond enthalpy, that means bond energy. Okay, so all these things we measure by using another techniques, by conducting chemical reaction. So physical property we can easily observe. What are the different physical properties? Color, odor, density, melting point, boiling point, etc. These are physical properties. It is easily measured in the laboratory. But chemical properties, it's required a chemical reaction to measure the properties. Bond lengths. Can you measure the bond length between two atoms? No. It is measured by sophisticated techniques. Okay, spectroscopy. Then many techniques are there. Many spectrum taken from the molecules, and that's why we measure the bond lengths, bond energy. Okay, also similarly many chemical properties are there. The configuration. We do not see a single atom. We cannot see the oxygen molecule which is in the air, but the bond length between the oxygen is 121. Okay, 121 picometer. We come into that measurements. Then we move to the measurement. For measuring, we need some units. For measuring the properties, we need some units. As earlier, English system, metric systems are used. But now, we are using SI system, System of International. What is SI system? System of International. In System of International, the basic units are, what are the different basic units? Length measured in meter. Length measured in meter. Time is measured in seconds. Mass is measured in kilogram. Mass is measured in kilogram. Current is measured in ampere. Temperature is measured in Kelvin. Then amount of substance measured in mole. 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 You heard about the term mole? I think you studied in 9th class. Amount of substance measured in mole. And the luminous intensity, light intensity is measured in candela. There are 7 basic units. Let's discuss one by one and its symbol and units. Okay, the other units are derived units. For example, velocity. Okay, what is velocity? the distance covered by object per unit time. So distance and time, it is a derived unity. Meter per second, kilometer per hour. The speed of a car is 60 kilometer per hour. So it is a derived unit, kilometer per hour. Usually we are using meter per second. Okay, so let's discuss the basic unit. I think you already studied in physics. Then basic unit. Length. The symbol is L. Measured in meter. Measured in meter. The symbol for units. Symbol of units. Here it is units. Symbol of measurement. Okay. So length is measured in meter. The symbol of the unit is M. Next is mass. Okay. Mass is M. Mass is measured in kilogram. In some textbook it is W. Okay. No need for worry about it. Kilogram. Kg. Kilogram. Then next is time. Time T, which is measured in seconds. Seconds. Unit symbol is S. Small s. Then another one is temperature. Thermodynamic temperature or temperature. Temperature T, capital T, which is measured in Kelvin. The unit is capital K. The symbol of the unit is capital K, not small k. Small k is kilo. And another one, current intensity. Current intensity. Current intensity I in ampere. So A, ampere A. Then amount of substance. Amount of substance. It is N. Small n. Amount of substance. The symbol is N. Mole. And the symbol is MOL. Mole. Okay. The symbol is mole. And now 1, 2, 3, 4, 5, 6. The last one is luminous intensity. Luminous intensity. It is IU. IU. The unit is centimeter. C. So these are the basic units for the measurement of properties. The basic unit of measurement. Then the other properties and their units, conversions, etc. are discussed in the next section. Okay, mass, then it's a different unit, volume, pressure, temperature, density, and the accuracy, precision, etc. are discussed in the next section.